So, welcome to the last talk in Museo of the Day. Yeah, I don't know. We don't have to do that. You can save that for the end. Okay, so this talk is going to be a little bit less computer sciencey than the last talk. We're going to talk about fun things. So first of all, go to the real title. How many of you would consider yourself artists? Far too many that I am comfortable with showing you my art. No, I'm joking with that. But my art, generally, I'm not good like just actually creating photorealistic things. I generally create things with a lot of randomness and interesting designs and other things because I'm not good at drawing or doing other things. I just find it's a lot of fun. But before we get into that, let's talk about who I am. So, I am Patton. I am the lead instructor of one of the cohorts in Galvanize. I've worked in the IT industry for over 10 years, but more specifically, the thing that most people really care about is the fact that I worked as a systems administrator with NASA for 8 of those years. So, I also stream myself a few times a week on Twitch TV while I program and do other things. I was preparing for this talk while streaming, so a lot of people around the world got to see me create little artistic things. Some of you may have actually seen me and interacted with chat. With that being said, Galvanize is currently hiring, so if you're interested in being an instructor, come talk to me or any of the other Galvanize staff who've been talking or hanging around here, and we'll get you set up with interviews and all that fun stuff. But I want to put this here so that way we can get on and have nothing but fun artistic stuff from now on. So, why art when burnout? I mean, burnout is a pretty serious thing in this industry. If we get burned out, it could be the end of our careers. And I'm not just talking about the end of the job. It could literally be the end of you programming for a long, long time. And that's because when you get burned out, just the idea of opening up a text editor and then doing something, that just like feels horrible. And you don't want to do that. You want to go like become a llama farmer or something. So I have found that instead of just like going on doing non-computer things, which is like usually what people say, like, okay, I want to go out and do photography, or I want to go out and do like bike riding or other things. All those things are great, but if you still want to program, and that still drives you, and you're sort of like addicted to that, and you want to feed that, then my argument is that art is a great way of feeding that while also refilling your sort of, well, resharpening your axe, so to say, which is going back to work with a refreshed mind in the morning instead of like, well, I worked on my own personal business app last night. Now I'm still tired and burned out. So, I started sort of getting into this art thing when I wanted to start making some video games. And I looked into a book called Nature of Code, which is written by Daniel Schiffman. It's available online for money or for free. And I started realizing that a lot of the things that he was making was very art-like. And a lot of the algorithms that you have to use are actually things that help you improve in the day job while making really cool things at night. So I started doing those more and more, and it's actually a lot of fun. So, types of art. as you can see, I'm not really that great at design. This is sort of my level of making things super, super awesome and interesting. That's why I rely upon randomness and colors and generations to do that for me. And I couldn't figure out a way to randomly create a slide that actually had words like this that weren't just splotches of color. So, back to types of art. We have, let's see this, nope, interactive art. So if I come over to some of these things that I made, interactive art would be something like this. This is one of the first projects I made when I decided to start making art type things. This is based upon an algorithm called random walk. And random walk, if I run this, is pretty simple. We just set up some colors, we click on it, and then it randomly chooses. Do I go up, right, left, or down? That's it. But it does it in a sort of like animated way, and in the end, we get this really kind of interesting thing on the screen. It's a drawing. It's a way for us to randomly draw stuff. After I did this, somebody looked at it and said, like, well, actually, it looks like you just made a random map creator for a fantasy world. Which, I mean, I can't really argue against that too much, but sometimes it does weird things, and sometimes it just makes really horrible splotches. But that is what happens when we rely upon random number generation to really do our art for us. So this is a really simple, easy way of just creating something. It's a lot of fun too. Okay. If we come back, we have animations are next. Now, of course, that included some like semblance of animation, but I wanted to learn more like actual animation, ways of having things move smoothly across the screen. So I played around with fireworks. So this is the idea of like, hey, what if I wanted to create something called particles, which is I wanted to create pixels and have them move smoothly, but I want to have a lot of them on the screen at the same time. And sort of display them around and create a firework display in this case. But these are the type of things that when I say art, I'm making things that make me smile. They don't necessarily have any actual money value to anybody else, and they look really cool when I'm looking at them. So I do have at the end of this entire sequence, after it runs out of the normal fireworks, there's a huge finale scene, but, well, actually, here it comes. Sort of forgot how long it took for that to come about. But one of the cool things about this is that you could just make these in a night. And then you have something to show off. Or it could just be for yourself. So the final type of animation that I have is just pure randomness. Now all of the previous one had elements of randomness in it. But in the first one we can choose where to start. And in the second one, it was, we were able to choose like, okay, what it's going to look like. But what if I combine the idea of the random walk with pure randomness, with color, and then just multiplied it many times, maybe like 1,000 times. Then we end up with this, where we basically have 1,000 random walks all going at the same time, and all of them are different colors, potentially. Now, when I first ran this, it was really interesting because it felt like I was looking at a Bob Ross painting where it's like, oh, look, we've got this splotch of color. It's going to turn into something really awesome, like a happy little tree or a house. But then you leave it running long enough and it's like, oh, no, it really is just a splotch of color. That being said, I can't really tell if I like the end result of looking at the splotches, knowing that I created this, or watching it all sort of come together and be created. Because both of them are kind of interesting to see, a little bit hypnotic. Like I probably could just stand here and watch it, But that's not completely why you came here. So I will close this down. Now, I have links, I have these on GitHub. And what I'm going to do is afterwards I'm going to tweet out links to the slides and links to these repos. So let's go back to the slides, because there's so much more interesting than that, right? Okay, so I do have a demo I'll show today. Now I'm not going to do full live coding, but I set up a system of branching where I can show basically how this could be made, and I also want to explain one of the libraries that I'm using to make it as well. This is going to be a type of art called circle pattern, which is the theory is, what would it look like if you took a fixed size and you added in a circle and you saw how many circles of random sizes could you add into a space? So let's see about creating it. First of all, here, put that up, and let's load the code up. All right, so to begin with, this is JavaScript. This is a standard web application, or I guess website, is not really how. To begin with, this is the only HTML that we need. And let me know, can you guys see that in the back? Excellent, okay. So I don't really have to do anything. I just bring in P5, and that's going to be the library I'm using, and my main.js. And that's it for right now. Now my main.js, I'm following P5's directions here. Now P5 is a library that's replicating processing, which is a language made for the Java syntax. It's also very common to see on Arduinos and other like IoT devices. So it basically just uses Java. It's also used to teach people programming and just to have fun and make really cool art projects. So this uses Canvas in HTML5, but the only thing I have to do here to create this circle in the middle of this canvas is create canvas, give it the size, and tell it to draw an ellipse right in the middle, size 50. So this is step 1. Let's move on to step 2. Check out step 2. So if we come over here, let's take a look at the code. I've made a little bit of an update here. I'm now creating a circle. Now I created it outside of here because I want the circle to be accessible inside of the example. It's basically abusing the global variable here. But the big thing is that we can now create a new circle. I'm going to use class-based stuff, so full ESX things. We just create a new circle, update display, and what that circle looks like is, hey look, update, increase your size, and display your ellipse, but now just use these. All right. That just gives us a circle that increases in size right in the middle forever. Okay, that's cool, but still not really all that awesome to look at, especially since the circle disappears eventually. For this, the circle hasn't changed at all. It's our main. Main is now just saying, hey, circles is an array, and we're just going to every single iteration here, add a circle, and then iterate through them and update them. Okay, that's cool. I need to move on to the next step before it crashes. So, step 4. Let's take a look at what this does so I can refresh it before I no longer refresh it. So it looks pretty much the same, but what you'll notice is that when it hits the edges of the canvas, they stop growing. So what I did was I added in here, inside of my loop, I basically say, hey, circle, run a check edges function, which, I mean, of course I have to write myself. Processing does a lot for you, but it won't do everything for you. And there's a lot of things you still have to do, which is where, this is where the skills of programming still come in. You're not having to lose any of that. So what ends up happening here is, in check edges, we have this really gnarly if statement. But it's not really anything strange. It's just saying, hey, if this dot location x, which is the center of the circle, if that, and then I have this like minus this dot size. Well, this dot size is supposed to be the radius, but I found out in P5, it's actually the diameter. So I have to cut it in half, otherwise I get really weird results. So if I do this, I just check like, okay, if that center spot plus the amount that is grown, if that is like should be impacting with the top, left, right, or bottom. And if it is, I just say like, hey, it's not growing. Like you're no longer growing. And then in main, we have to now come in here and say like, oh, okay, if we can say update. But in here, in update, we're only going to increase the size if it's red. Cool, but we're still adding infinite circles, so this is still going to crash my browser. So, step 5. Let's take a look at what this does. So it doesn't feel like it's doing anything different. Let's go take a look at the code. And the big thing is like circle looks pretty much the same. We have to take a look at here. Now, what we're actually doing is we're checking to see when we place a circle randomly in here, if we've placed it inside of a circle. This way we don't add infinite circles forever. In fact, this won't crash my browser anymore because these circles are giant. And therefore, no circles can be added in. Now, of course, I think like right up here in the top left, there's space for a circle to go. But what's happening is every one of these frame ticks, it's trying to place it in a random location. If it's inside a circle, it just says, okay, next time around we'll try again. That means that it might take a while before it gets to here. Now to do this, it's pretty simple. We just have to loop through and hand it a location, and then it goes. Now, before we go too far on, because now I don't have to worry about crashing the browser, I want to explain a little bit about a sort of mathematical idea which is called vectors. So, when I first started playing with this, vectors were a scary thing I'd heard a lot of, but I had never actually played with. I thought like a vector is like this line and an arrow, and you have to figure out, you have to do it if you're ever doing like GPU programming. Turns out, super simple. A vector is simply an XY coordinate. That's it. Nothing more. So when I do this create vector, I hand it an XY coordinate, which is simply just two numbers. Now, processing gives a lot, or P5, gives a lot of really cool methods that we can add into vectors. Like you can add two vectors together. So if you ever want to make a game in which you say like, okay, I want to shoot a bullet out, and you want to detect if the bullet is like hitting someone or on its path to hit someone, you have to like, okay, I have the vector of where the enemy is and a vector where the hero is, and I can subtract the vectors, and that will give me the line of where they're going, and all sorts of interesting math problems at that point. Now for this one, we don't really have to care that much about that. We just say, hey, vectors, go there and be happy. Okay, this is cool. Let's move on to the next step. Step 6. Let's take a look at what we got here. So with this one, we now finally start to say, okay, for every single circle, I want you to collision detect against other circles. And if you collide, stop growing. Now this is where it gets really interesting, because how to do this, you have to check every circle while they're growing against every single other circle. Well, that means a really awesome for loop inside of a for loop. Yay. Yeah, I heard a super enthusiastic yay in the audience. I had to write this one a couple times when I was writing, because I kept on trying to get clever and trying to make it easy to read. And then that just ended up making it not work, or like they would collide really early, or never collide at all, or sort of sometimes collide, or all of them would collide once. Obviously, this is the most complicated part of this entire program. And the thing is, there's not really too much you can do about it. When you're making this type of, in a game or in art, you need to sometimes do weird things, especially if you're going to do arrays of 1,000 objects and then compare each 1,000 objects against 1,000 objects. This is also the reason why my computer's fans have turned on high and why I have to plug into battery, because when you start playing with these things, you find out that that 8-hour battery life that MacBook Air is supposed to give you is really only about an hour and a half when you run the CPU at max. So, this is this awesome thing. Now there's one thing I want to sort of point out here, but this is more of this magic that vectors give us. P5 gives me this dist function. I do not have to manually calculate the distance between two vectors. What I do is I just run this function. I say like, hey, here is the x location. So here's like one coordinate, like the x of one circle, the y of that circle, and then the x of the other circle, and the y of the other circle, and it gives me a number in pixels that is the measurement of the distance between those 2 points. The other part of it is I just need to simply add the sizes together. Now, when I first did this, I forgot that the radius was really the diameter, and so the circles would stop halfway before meeting each other. So I had to add in the fun division by 2, and then we get this entire thing. Simply, all you have to do is check the distance and compare it to see if it's less than sort of the global size between the 2 circles. Now, I did this -2 because if I don't, each one of these circles actually has a very tiny border around them, a 1 pixel border each. So they overlap by a pixel. So I just -2 up here, and then just say, hey, circle stop growing if this happens. I also felt I needed to use for loops for these, so I can use break, because for each does not give you the ability to break out of it. And if you hit them all, or like you say like stop growing on like the second circle, you don't want to like go into like a million circles later and just keep on checking these. So this is pretty much it. Like this is pretty much the how to make the art with this. There's only one last thing to do, which is to add color. But that's actually not very hard, not especially compared to what we just did. So with that, nothing changes in main. Although I kind of did this in main because I was thinking I might want to add in like some other ways of doing color generation. What I do is I just say, generate every single tick whenever I'm going to add a circle, generate a random color, which, if I find this function here, is just going to give me red, green, and blue. That's what we're going to base it on, RGB. And it's going to be a random number between 0 and 255. I have to put 256 in random here because it is exclusive on the top round. The other thing is, this could easily be done with math@random, the one that JavaScript gives you. Processing, or P5, gives you their own random generator, which as far as I can tell is pretty much the same thing as the random generator, as JavaScript random generator, except this one, you don't have to do math.random, just call random. It's for lazy developers like me. Inside of circle, what I can do is change fill and say, okay, the fill of this is going to be this dot red, this dot green, this dot blue. And then just bring that into the constructor. And that, when I refresh this, will give us exactly the same thing here, except with colored circles. So I was playing around a little bit with how could I make these look even better, potentially. Like, do I want to fill this in as quickly as humanly or computerly possible, and just force it to add in a new circle every single frame tick? But I found out that I kind of like having the white space here. It gives the eye something to rest on. Otherwise, the colors kind of make it really crazy. That being said, if I leave this up here forever, it will just eventually fill in completely, and there will be 0 pixels of white left, because it will, one day, statistically speaking, the random generator will find that exact pixel to go into. Now, I don't really have anything else. That's the demo of the thing. I know it's not a super long talk, but I wanted to give some time for questions, and then I can also show this this sort of forming what we're doing. Okay.
Can you give an example of how doing this part then played a role in helping you do your work as well?
Yes. So the question is how have I found doing this art has helped me in the day job, as it were. What I have found is it helps with the algorithms part of the sort of the computer science aspect of it. What I found is if I want to have a canvas, but that's more than 1024 by 768, and I want to have many more circles on here, that's going to slow down the computer. It's going to get really slow. So it forces me to find the really good algorithms that will do that really fast. Basically, I have to worry about the big O. And that's not something that in our day jobs we usually think about, except when it hits like the really tough problems. And then when we get those tough problems, it's really a drag, and that's where burnout starts hitting, because you're like, I gotta spend again another day thinking about how to make that tiny database query a little tiny bit faster, or I have a billion things I have to iterate through and display to the user. Okay, I'll do that again for today. But doing that at home is like, I have to figure out how to add a million items onto my firework and then want them to collide with each other. That's fun. Mm-hmm. That doesn't burn me out. That makes me excited. But then I go in and I was like, hey, I can use that algorithm here. I just adapted it a little bit. So that's how I found that helps me. Let's do in the back.
When you're starting out with a blank canvas, what does your creative process look like? Kind of how do you decide where you want to go and what initial impulses you usually follow?
Great question. So the question is, when you're staring at the blank screen, how do you go there? Because that's the same thing with any artistic or creative endeavor, like creative writing, programming, anything. And oftentimes for me, what's helped is going onto YouTube and watching other people. So Daniel Schiffman, the person who wrote Nature of Code, he has a YouTube channel where he does coding challenges where he takes an algorithm or something in nature and tries to replicate it. So a lot of those things have inspired me. He's like, I want to create something like that. Other things, I'll go through Google image search and just say, that's really interesting. But besides that, I might literally be looking around and saying okay, that fire image over there, that looks really interesting. I wonder if I could figure out an algorithm that would allow me to create a lot of particles and have them come down. So I didn't create something exactly like that, but I was thinking about fire. And I decided to make something similar to that. I don't know if I have it on the visualization on here. I can check to see. Go back. Do I have fire? I do not have fire on this computer. But I have basically this animated where every single frame it creates about 100 more of these little tiny red dots. But I used color to try to make them colored sort of like fire, and then they flow up, but I'm also using random numbers to try to make them go left and right as if wind was hitting them. And that's how I got inspired by it, by just sort of looking at other people do it. Alright, other questions? Let's go.
Can you just recommend some resources for learning P5? And also, I just wanted to talk about P5 real quick.
Yeah.
Is P5 a JavaScript layer for processing? Does it run processing in the background, or what is it? I missed that.
Warren McCarthy developed P5 as processing foundation. They sponsor through grants and things like that. So this was a special project that she did. And so it's running many of the similar things, but it's not actually running the Java layer processing.
So there was JavaScript?
So it is pure JavaScript. So the question is, what is P5's relationship to processing itself? It is pure JavaScript. It is fully supported in the browser because it is just a JavaScript library like jQuery or anything else. What I recommend this book for developers. So this book assumes that you know how to program already, and it is used in Daniel Schiffman's master course at New York University. So it is not for like light of hearts. It's not like a great way to learn how to program, but it is a great, like it uses processing for all the examples, and anybody who knows how to develop will be able to follow along and learn quickly enough to also learn the things like, oh, how do Perlin noise like algorithms work? How do these other interesting, more artistic and game type systems work? This book is, as I said, on naturecode.com. You can name your price for it, and 0 is one of the possibilities. Or you can buy it. I got a physical copy of this. All right.
So I got a question. Whenever they're growing, I notice that as soon as they touch each other, they immediately stop. Is there a way to have them go grow, but then somehow know they're about to collide and just ease into the stop rather than immediately stop?
Yes, so the question is there a way for me to change what appears to be the animations of it so I can like make it faster when growing, make it slower when growing, and like maybe as they come together, slow down? Absolutely. So these are the types where like you can go home and take this code and add to that. And where I would suggest that code be is where you check if they're in this lovely algorithm here. You can find out, hey, look, they're really close to touching. So right now I'm only checking if they are touching. I could check if they're several pixels out. And if there's several pixels out, I can say, oh, I can hit another flag in that class and tell the instance, okay, well now if you're there, increase your growth size by now half of what it was before. And then it can even cut that in half as it goes on to get really slow. So, yes.
I don't know a lot about Canvas, but this seems like it would lend itself to some really cool like background, like hero images and stuff for software for sites. Can that be dynamically sized, and does that affect how it's laid out? Does it resize with the browser and stuff?
Yes. So the question is, can we do things for like our normal websites or apps using Canvas so we can resize them and make it responsive, but also have the really cool animations and make it easy? And the answer is yes, but it takes work. So if we notice at the beginning here, I have this create canvas 1024 by 768. This is static. So if I come here and I resize this window, the canvas size doesn't change. To change the size of the canvas, because if I set at the beginning here, I can say const canvas equals create canvas. This canvas variable now actually holds that canvas itself, and there's methods on it that I can run to manipulate it.
What's your favorite part about Twitch streaming? And what's your favorite thing that came from it, I guess?
My favorite part from Twitch streaming and what came from it. I think interacting with audience and just learning how to code really quickly. Any other questions?
Have you ever tried any OpenGL stuff?
Sorry, what was that?
Have you ever tried any OpenGL stuff?
I have played around a little bit a long time ago. I have not played around with the OpenGL on web development stuff, but it looks really cool, and I eventually do want to try it. All right, with that, I'm going to say this session has closed. The only last thing that we have today is that after party.
Nice.
So I'll see you guys there.